Imagine a volcano so cold it spews frozen water instead of lava. A mountain of ice erupting in slow motion on a world 3 billion miles from the sun. When the New Horizons spacecraft flew past Pluto in 2015, scientists expected to see a dead, frozen rock. A relic from the early solar system, frozen in time. But what they saw shocked them. Pluto was alive, not with flowing rivers or shifting continents, but with something far stranger: ice volcanoes. Not just one or two, but entire regions covered in massive, frozen mounds that looked like nothing we'd ever seen. These weren't ordinary mountains. They were cryovolcanoes, volcanoes that erupt ice. And their existence rewrites the rules of what's possible in our solar system. Let's start with what makes this so bizarre. On Earth, volcanoes need heat, magma, pressure, tectonic activity. Pluto is one of the coldest places we know. Surface temperatures dip to -400 degrees Fahrenheit. It's so far from the sun that daylight looks like deep twilight. Everything should be frozen solid. And yet, here are these enormous structures, some as tall as Mount Everest, with deep central pits and wrinkled, flowing surfaces. They look like they oozed something thick and slushy onto the surface before freezing in place. But what could possibly be warm enough inside Pluto to make ice erupt? To solve that mystery, we have to look beneath the surface. Pluto isn't just a simple ball of ice. It has a rocky core, probably still warm from the planet's formation billions of years ago. That core is wrapped in a thick mantle of water ice, but not ordinary ice. At the temperatures and pressures inside Pluto, water ice can behave like soft plastic. It can flow, deform, even rise toward the surface if there's enough heat and pressure. And that's where things get interesting. Because Pluto has another hidden source of warmth: radioactivity. Elements like uranium and potassium, trapped in the rocky core, decay over time and release heat. Not a lot, but on a small world like Pluto, it might be just enough to keep parts of the icy mantle soft, even slushy. Now picture this. Deep below the frozen nitrogen and methane surface, there are pockets of warm, watery slush. Over millions of years, pressure builds. The slushy ice wants to expand. It finds a weak spot in the overlying crust, a fracture, a thin area, and begins to push upward. Slowly, incredibly slowly, it rises. When it finally breaches the surface, it doesn't explode like a volcano on Earth. It oozes. A thick, icy slurry spreads outward, piling up layer after layer, building a mountain over eons. That's a cryovolcano, a frozen fountain. A slow-motion eruption in the dark. The largest of these structures on Pluto is Right Mons, a mountain about 3 miles high with a central depression 4 miles across. It doesn't look like a typical volcano. It's more like a giant blister, with wrinkled, flowing sides that suggest multiple eruptions over time. And it's not alone. Nearby, Picked Mons rises just as high. These aren't lonely peaks. They're part of a vast, geologically active region. And the material they erupted isn't just water ice. Spectrometers on New Horizons detected ammonia mixed in, a kind of antifreeze that could keep the icy slush mobile at much lower temperatures. That means these volcanoes could still be active today. Not erupting in fiery plumes, but perhaps slowly leaking, reshaping the landscape in silence. What does this mean for our understanding of Pluto? It means this tiny world isn't dead. It's geologically alive in its own slow, frozen way. And if Pluto can have active ice volcanoes, then other distant icy worlds might too. Moons like Europa, Enceladus, Triton. Places where hidden oceans and internal heat might create similar phenomena. Pluto has become a model for a new kind of planetary activity, one driven not by fire, but by ice and antifreeze and radioactive warmth. But the most thrilling idea is this. Where there's warmth and water, there could be life. Not on the surface, of course. It's far too cold and exposed. But deep below, in those slushy chambers where cryovolcanoes brew, conditions might be mild enough for chemistry to begin. We don't know yet, but the discovery of ice volcanoes on Pluto opens a door. It shows us that even in the darkest, coldest corners of the solar system, worlds can be dynamic, complex, and surprisingly alive. What other frozen worlds do you think might hide secrets like this? Share your thoughts below, and don't forget to subscribe to Nature Unlocked for more journeys to the edges of the known universe.